So in 2017, I started doing freelancing. And in 2018, I was interviewed by Ben Schumann's podcast, and he asked me, how do you get clients? And I was using a lot of freelancing platforms. And my answer was, I try to find people who need things in Excel, and I tell them, don't use Excel, use AnyLogic. So this is an example of that. And not only that, here is an example, which is a really small project that ended up being really long for the client because they started using Excel, and then they tried to use a simulation tool that is not AnyLogic. That was also a mistake. So let's start with this. So right now we are a small simulation company, not a freelancer directly anymore. And we have simulation courses, but I was already introduced, so no need to do that. Now, who is the client? Unfortunately, they didn't want me to disclose who the client is in this conference, but it's one of the biggest multinational logistics British companies. So you might you can maybe guess who it is. And they have operations in all continents, and they work in automotive, retail, technology, and rail. So it's a pretty big client with a defined problem. So we will talk about the problem, which is related to high congestion, and in particular, what material handling equipment to buy to be able to fulfill the demand they have. We'll talk about the solution, what results you get in Excel, in AnyLogic, and these other simulation software they used. I will show you a little bit of how we decided to do this simulation model in AnyLogic, and I will show you the features, and you can try to guess yourself how you would do it. And we'll see the results, which is quite an interesting thing to see. Now, this is the warehouse. It's quite a typical one. You have a bunch of racks, a lot of rack systems that you can see in different colors. These different colors represent different kind of racks that have different products. They have different aisle types, like more narrow or not, higher, lower, and so on. And you have docks, typical warehouse. And there's no really connection between the docks and the pallet racks. So what you need here is a set of relay points. These relay points act as the communication between the docks and the pallet racks. So something happens in the docks that puts the pallets in these relay points, and then the material handling equipment can take these pallets to either a pallet rack or through cross-docking to another relay point, or from the pallet rack to the relay point. So it's a pretty simple material flow problem. Now, there are a few other activities that occur here. One of it is the waste collection. So there's a counterbalance truck that goes around the whole facility collecting waste from the aisles. And they have to stop in the aisle, collect the waste, and then continue. This causes congestion. They also have to recharge batteries. Some of the material handling equipment needs to do that. And they have to go all the way to the end of the facility, also creating congestion. And finally, you have parking. So some forklifts that have nothing to do need to park in a place that will also cause congestion. So why is this so problematic? Because you only have one highway in which everything is being moved, almost everything. This highway is the one you see here in red, and this is where the congestion occurs. So the question that we want to answer, is it possible to fulfill all the orders? Simple question. Now, there are a few things that are important too, that this client needed to know what material handling equipment to buy. So they have a supplier that proposes something. So they have taggers that can carry multiple pallets. They have counterbalance trucks that can collect waste and handle tagger load. So they take the pallets from the taggers and they put them in the relay points, and vice versa. And you have other reach trucks and order picking trucks who go to the different kinds of pallet racks, depending on how tall or how narrow the aisle is. So what equipment to use in order to fulfill all the orders? This is what we want to solve. So the Excel model is much bigger than this, but this is the final result, where you see a heat map of the whole situation in the warehouse. So each row represents a time of the day, and each column represents a section that is arbitrarily chosen from the highway that I showed in red. So we see in Excel that the most problematic moment at 1 o'clock, you have around 2 trucks per minute going through that section, which sounds pretty okay. That doesn't seem like something that will create a lot of problems. But you have to consider the things that Excel cannot do. So one of them is it doesn't account for deadlocks. Like sometimes the situation is so congested that a counterbalance that needs to take pallet from a tagger cannot reach it because there's too many things in between. You don't account for waiting times, and you don't account for bottlenecks. We all know that if you want to account for bottlenecks, you need to do simulations. So the stakeholders didn't really trust fully this model, even though it's pretty, it's a good place to start maybe, but this was already 1 month of development. So next 3 months of development were done on this other simulation software, which name I don't remember. But they did this for 3 months, and at the end of this work, they found results that are similar to the Excel, because there was no collision detection. So they asked the modeler, can you do the collision detection? And the modeler says, no, this software is not possible. It cannot handle that. So is it a problem of the software or the modeler? I don't know. But they had to call me and say, Felipe, we need you to save us because we have only 1 month left, and we have been spending 4 or 5 months in this project, which is not such a complicated project. So I said, don't worry, let's do it in 3 weeks. And the question now is, okay, I will use AnyLogic because it has all the features I need, but how do I do it? Should I use the process modeling library that doesn't have collision detection, in which case I fall into the same problem as the other software? Or should I use agent-based? Or should I use the material handling library? And that is a question that I faced a lot, and we all face a lot when we start doing simulation models, in particular when you have to choose between agent-based and discrete events. Even if you can do multi-models, you need a base. And this is always a question to have. So let's see what the characteristics of the movements are, which are pretty strict. The client was very strict in terms of how the movements were seen in the simulation. So one thing is that you need a safety distance for a truck to be able to make a U-turn from one aisle to the other aisle. And this safety distance is a parameter. So that means that you have to be able to test if these different safety distances and see what the results are depending on this distance. So this has to be parameterized. So the same way, if the truck needs to turn right, it needs the safety distance for both sides of the road. So this seems pretty simple. Now, there's a movement that was a bit scary, because generally these trucks, they act as AGVs. But in some cases, they need to overtake a multitude of other trucks that are doing things in between or are parked. And you have to consider that the client really wanted to see this movement, but also need to consider that the safety distance between the trucks that are coming in the other direction and the truck that needs to overtake this combination of counterbalance trucks and taggers. So this is another feature. And another one is that you need to create this line of forklifts that need to cross, but they can't. Even though there's not really an obstacle in between, the fact that there is a counterbalance at work, for safety reasons, everyone needs to stop. And there are other features that I don't mention here, but the question is how you do this. And you probably had in your mind how to do it. And maybe you can use the material handling library. Maybe it will be more difficult. I don't know. We decided to use agent-based modeling. The good thing is that with agent-based modeling, you have a much more control of everything you're doing, or of all the detailed movements of all the trucks. And you can add collision avoidance, and you don't need to be so crazy about all the features that need to be implemented. You need to implement only what is necessary. You have to build it from scratch, so you lose the opportunity to use the material handling library characteristics that already has collision detection, but also acts as a black box, and you cannot control absolutely everything. But I wanted this control. It was a bit scary for me to not be able to control when the client was so strict about seeing the movements in a particular way. So we decided to use agent-based modeling. So this is, I don't know if it starts. Yeah, so this is a simple one where it turns red when it goes around. So you have these little movements, and then you have to wait when the other forklift is coming on the other direction. So this is pretty simple. Okay, so now we see on this other video the much more complex movement, where you have all the forklifts waiting for kind of a deadlock situation in which there's this guy in the middle of the road who was, but it's difficult to see, but you can see a little bit here how the whole simulation works, where everything has to stop. And we have all this collision detection only using agent-based. So we built our own collision detection framework that allows us to do these whole movements that the client really wanted to see. And the same thing here, where you have the pink one that needs to leave and make maybe a U-turn or turn left, and it has to wait for the safe passage. So all these things were built from scratch. And it's not so difficult. And we did it in quite a fast, low amount of time, just 3-4 weeks. So the interesting part is that we have here we export all the information generated by AnyLogic as a raw data, and we import it in Power BI. So in Power BI, we can see all the data that we need to see, and this is one of the examples of data points that we have, in which we see that in area 9, the density was almost 5 trucks at any given time in peak hours, which is much, much higher than what the Excel and the other simulation model was saying. And this was much more trusted because the simulation actually represented what the client really wanted to see. So when we saw a way to answer the question, we saw this graph, which is how many orders are unassigned at the end of the day. So you see the whole day here from 6 a.m., where the operation starts, until midnight, and you see that you have thousands of orders that are not fulfilled in comparison to the demand that they wanted to achieve. And this was really the trouble, because the Excel seemed to have really good results. But in AnyLogic, this was showing real congestion, like the real thing. And this is what we got. So it was not possible, based on the supplier offer of material handling equipment and operations to be held in this warehouse, to supply everything that needed to be supplied. So the demand was not fulfilled. So this simulation was given to the client. They had a configuration file where they could change the different material handling equipment, putting more small forklifts and less staggers. And this was what they did in order to decide what set of material handling equipment they would buy. So they actually created a completely new fleet using less staggers and more single forklifts. They created a new deal with provider, and from what I heard, the provider was a bit angry because they changed the deal. But it was necessary in order to be able to ensure that the operations were going to be fulfilled properly. And the last thing I heard a few months ago is that the current operations are running pretty smoothly in the location, so the simulation actually helped them quite a bit. And this is all I have, and I'm open to questions. This is the information of my company, and yeah, I hope you enjoyed everything I said.
I have a question about when you were doing the complex movements. You said that the client really wanted to see that. I'm interested in how they got to that mindset, given that they started asking for an Excel model, which was obviously not going to show them any movements. Was that because they became convinced of the value of the simulation model, or how did you, like, were they planning to use the visualization of the movements in any way, or is it just to get an accurate reflection?
Yeah, so the question is, how do they get to want particular movements when they started only with Excel? So this is a pretty big company, so there are different levels of hierarchical interest. And there was this interest to do this, but they didn't know how, so they go down the hierarchical path into some collaborator that will do this in the best way they can. They show that to the higher management or higher directors, and the higher directors say, no, we want to see this happening in real life. And you see, it's kind of a hierarchical situation. Like, when I showed the first model that didn't have some of the movements you see, they were saying, no, but wait, I want this movement also. I want to see this, and I don't see it. It's like this was, I think, director level, and that was it. You know, it's not that they changed their mind in what they wanted to see. It's just a hierarchical level situation in the company.
A couple of quick questions. The warehouse management system should generally address these issues, right? The movement, it does provide the movement types, for example, what can move in certain times, what cannot move. Wasn't it not doing the warehouse management software, creating the congestion that you showed? There's a beautiful graphic, by the way.
Okay, thanks for the question. Like, the question is about the warehouse management software that should show the movements. So this was a new location. I don't think I don't know about the warehouse management software. If they had one in that location in particular, this was a completely new location. I think brand new in terms of the layout. So they wanted to simulate it in order to be able to decide what equipment to use. And it's not about the movement of what's possible, but you have to consider safety elements that you don't see in the warehouse management system, and you want to see if the way you want your trucks to behave are actually aligned with what you want to fulfill in terms of demand. I don't know if that answers.
Okay, that answers, thank you. Second question is, how did they end up resolving this issue?
Sorry, can you ask again?
How did they end up resolving this issue finally?
So the issue was in a resource situation. So what equipment to buy? The simulation allowed them to decide what equipment to buy. Because, as I said, the configuration, if you have the simulation tool, I didn't show you this, but you have a configuration file that allows you to determine what are the resources you want to use, and you can plug that in as an input to your simulation and decide whether you are able to fulfill the demand or not. We didn't do the optimization part, there was no time, but we used the simulation in order to be able to decide what equipment to buy. So that was the main issue. And when they changed from using taggers to singles, the situation was much better. That was in their part, I gave them their tool, and they just gave me the information about what they end up doing. But they used the simulation in order to decide what to buy. And then with the simulation, they decided what to buy, and they ended up in a situation where they were able to fulfill the demand with a particular set of trucks. I don't know exactly what the trucks they ended up using were, but that was it.
Thank you so much for the talk. As always, it was a good one. So the couple of questions. The first one was a small question. You said that the safety distance was a parameter in the model. And I'm wondering, one would imagine that safety distance is defined exogenous to the model. It's defined based on the hazard of a crash or so on. So in your model, did you find that the safety distance played a large role at all?
So as I said, my job was to provide the tool for them to do their own analysis. So what they would, I don't know if they changed the safety distance or not, but they had the opportunity to do that. And with all these inputs, they ran a bunch of different simulations that they would then be able to compare it in Power BI. You could export the data from various simulation runs and have all the simulation exports available for Power BI so you can do comparisons, which I didn't show you here, but you could do that.
Great, thanks. And the last question is, it sounds like this organization wasn't leveraging the capacity for simulations more broadly, because it sounds like they have more than one location. And I'm wondering if you built the model in such a way that they could apply it for other locations, or if it was built specifically for this one, and if so, do you know if that institution has decided that, like, hey, we like modeling and simulation, let's do more of it?
So they do a lot of analysis in warehouses. They create layouts. They do all this kind of stuff. They don't have a simulation team, but they have a lot of teams. So they worked on this simulation with me, but they had bad experiences with simulations in previous projects, a lot of bad experiences. So they didn't really trust simulations a lot because of that reason. And you can see also even the new simulation they did before the one I created was also a bad experience because they were not able to solve the problem. And there was another project I did for them before that also they had a bad experience with a simulation that actually didn't solve the problem. So that was the situation with them. Now, they cannot reuse the same simulation for other locations because this location is unique, but the framework can be used, and we're always in conversations to do new things with them.
Thank you for your presentation. It was really good. I just have a little technical question. I saw that in your facility, when a forklift that is blocking the way of another forklift behind it, it will go around. How did you achieve it?
So the question is, how do you make a forklift go around another forklift?
Yeah.
I don't know how to answer this question. It's just, you can, with state charts and agent base, you can do anything. Like, if you want the technical answer, it was just a state chart that had a state of waiting and a state of going around, and that's it.
I mean, how do you specify the path if it was not there before?
How to specify the what?
The path, like it will need to
So,
go around, right?
So yeah, so how do we specify the path to go around a forklift? I mean, there's a mathematical model where you can create a circle that represents something between the two forklifts, and you use the formulas related to that circle to be able to follow the path of the circle.
Okay.
So we had all these mathematical formulas in the model.
Okay, thank you.
You mentioned deadlocks in the presentation. Did you have a lot of problems with, how they were set up on the highway, with certain aisles maybe having trouble getting out, being blocked by natural backups? How do you manage that? Did you get to play with some of the rules with how the AGVs moved around?
Yeah, so the question is basically what did I do with the deadlocks and what kind of deadlocks I got? Something like that. And how do I play around these deadlocks?
Yeah, did you have any ways to manipulate how you could, I don't know if they had rules for the AGVs already that you were just mimicking, or if you got to play with some of, how you could manage those rules yourself, priorities and things like that.
Okay, yeah. So the deadlocks occurred for only one reason, which is you have a tagger that arrives to a location to unload or load something, and to do that, you need a counterbalance to be able to help on the download or loading activity. Now, if the counterbalance is too far, if the closest counterbalance is too far and there's some other forklifts in between, you can create a deadlock because nobody can go anywhere. So we had to have these discussions with the client. So what do you do in these cases? And for example, you can say that there's some conditions, for example, that the forklift that was creating the deadlock would need to leave and make like a U-turn and come back later or take another order somewhere else in order to be able for the traffic to give space, and then the counterbalance would get into the place it needed to get. Now, another thing that you need to do is like the tagger sometimes couldn't drop something in a place because it would create a deadlock, so we also discussed, and that means that the counterbalance would continue its way and go somewhere else to do other activities. So this created some sort of inefficiencies, but these inefficiencies were real, and we were trying to see kind of the worst possible situation instead of trying to solve problems more realistically, because in reality, you can easily just have a conversation between the different people that are working there and solve the problem. But in a simulation model, you need to create rules. And the idea was to see what would happen in a kind of bad situation. So that was kind of the game to play.
Hi, thank you for the presentation. Over here.
I don't see anything. Okay.
Over here. Just want to say thank you for the presentation. We've actually built pretty similar simulations in the past. There's kind of two main technical questions that we have for you. First one is, with the identification that the highway system is one of the more critical paths, that's basically the problem that you're trying to solve. How do you identify between two different agents, whether or not they're two different forklifts or two different tuggers? How can they interact with each other? Particularly the one that we were discussing was, how does a vertical aisle single forklift know when there's space in the highway to actually do the U-turn when there might be space as it's approaching, but there might be other agents that are coming in through that path that are restricting the movement then?
One way generally people think about this problem is just trying to iterate among all the forklifts and see which one is closer, or if there's any one closer to you, and so on. But this makes the simulation pretty slow, and it's not a very good way to do it. So the way I did it is by indexes. So this is kind of a linked list or an indexed list of the existent forklifts in different, you could say that quadrants. So if you if a forklift goes from a quadrant to another quadrant, it changes its index. So what I'm looking for are forklifts with the same index or index +1 or -1. And this also accounts for the ones that are in any direction, because I only see indexes based on quadrants. And this is kind of the basis of what I did, but there's a lot of kind of more programming.
Yeah, absolutely. Thanks for the insight. We do a radial approach with ours, so yeah, absolutely. Thank you so much.
No problem. I think that's it. Yeah? Okay. Thank you for the applauses.